Elizabeth with Hamilton Native Outpost, and I'm here in this beautiful silvopasture, savanna, whatever you would like to call it, but it's a diverse native grassland. So we have these different plants all mixed together, growing in a grassland like the bison would have seen. And what's on my mind this morning is the fact that these grasslands, these plants work together in such a way to hold the water in the soil. We make an environment where if we can get the water from a rainfall event in the soil, we can hold on to it, and that's important in so many ways. For the plants, the animals, so many ways. And so I'd like to explore those thoughts today. So the thing that holds water in the soil is organic matter. We call it soil organic matter. You can call it soil organic carbon. You can think of it as carbon dioxide from the air that is stored in the soil. It's what gives your soil a dark color. And so often a soil is dark on that top part, and then as you get deeper down, there's less plants' roots to make organic matter. You get less dark colors. You get less organic matter, in other words. But this organic matter is what holds the moisture in a soil. So I've got this bucket of water here, and I've got a sponge. And of course, at first when it rains, the water just runs freely out of the sponge, out of the soil. It goes into the soil and it goes through the soil because the soil can only hold so much water. But what we want to see our soil do is to hold more water than less. So this is a pretty good sponge. And so it holds a lot of water. So to look at it another way, I suppose I've got another couple sponges here. These sponges are pretty much the same size, same thickness, same dimensions, but they're going to hold way different amounts of water. And so the yellow sponge is a much better holder of water, and we want our soils to be like this rather than like this. This is like a dry desert-like soil, whereas this one holds water for the plants and the animals that are living in it and on it. So just to look at a little bit more about what is soil organic matter, what is making that sponge. So this is plant or animal material that is really unrecognizable. It's decomposed. So if we have a plant here, and that plant comes to the end of the season, or however it happens, it falls to the ground. We'll pretend this is the ground. And then the microbes start to chew that up. And at some point, you can no longer identify that plant species anymore. It doesn't have any identifiable characteristics. At some point, it just turns into brown compost, if you will. So we call this organic matter or soil organic matter. And so this is how it's made, is the dead plant material or animal material plus the microorganisms in the soil, and you end up with organic matter in the soil. So this sponge is super important that's provided by this. So how does a diverse native grassland fare as far as organic matter? How does it fare as far as its sponge? Is it, this sponge that has a lot of water, that yellow one there, or is it this green one that really doesn't have much water? How does ours fare? Well, we actually, when we established one of our diverse native grasslands, we did so with the forethought to take soil samples ahead of time. So we went out and you take a little core, you dig about a 6-inch little tube of soil, if you will. You dry it out, you crumble it up, send it off to the laboratory that analyzes the organic matter. So we did this beforehand, and we did it again after we had established the diverse native grassland. So prior to being in a diverse native grassland, it was in fescue. After we converted it, it was growing 100 species of native plants, all growing on this 60 acres. And so how did that fare when we took those soil samples pre and post establishment of a diverse native grassland? Well, what we saw was that the organic matter increased by about 1%. Now you're like, okay, 1%. If I got 1% on my chemistry class test in high school, I would fail the class. And while that's true in chemistry class, when we're talking about soil organic matter, 1% is actually a pretty big deal. So there's a statistic, I found it on the Natural Resources Conservation Service website, but that statistic is that if you have an acre, so if you're not familiar with what an acre looks like, think about a football field. If you have a football field and you take the soil 6 inches deep, so something about like such, across that whole acre, you can hold 27,000 gallons of water with a 1% increase in organic matter in that top 6 inches of soil. So I'm like trying to think about this. I'm like, okay, how many barrels, 50-gallon barrels would this be scattered on a football field? So finally what I did is I'm like, let's get this down onto something I can imagine. Let's get it onto a 1 foot by 1 foot by 6 inches deep. So with me, I have brought something that's approximately 1 foot by 1 foot. And if we picture it being 6 inches deep, then we have our scenario for calculating, well, how much water, extra water, with a 1%, measly 1% increase in organic matter, how much extra water can we put in the soil that's this big by 6 inches deep? So what we found when we had converted this fescue pasture to the diverse native grassland, in this 1 foot by 6 inches deep area, if you convert that 27,000 gallons per acre to this area here, we found that you can hold that much extra water in that soil, that much extra water in that soil, and that much extra water in that soil. This is equivalent to about 0.62 gallons, so 6/10, a little over 62 hundredths of a gallon of water that we can hold in an area that's 1 foot by 6 inches deep. Now from the standpoint of the plants and the animals growing here, this is a big deal. And it was just 1% organic matter increase. And you don't get to 100% usually in most soils organic matter, but this 1% organic matter ended up having a big consequence for our soil as far as the amount of water that it can hold. Another way that I like to visualize this actually is to think about, this is about equal to a half of a milk jug, a little over a half of a milk jug. So that much extra water in something that's about the size of a nice sized dinner plate that's 6 inches deep, so a nice sized bowl maybe that's 6 inches deep, we can put about a half of a milk jug worth of water into something that's 1 foot by 6 inches deep.
Round of applause.
Thank you, Danielle. One last way to think about it is actually, if you take 6 inches of soil, you can hold 1 extra inch of water. So a 1 inch rain, with that 1% organic matter increase, you can hold 1 inch of water in 6 inches of soil. It's a pretty big deal. So when we did these initial soil samples, we didn't think to test deeper than that first 6 inches. But of course, the root systems of the native plants go, 10, 15 feet deep sometimes, depending on how good the soils are. But these deep soils, these deep root systems, mean that we can build organic matter way deep into the soil as well. So we actually came back, like 4 or 5 years after this diverse native grassland was established, and since we didn't have any data from before, the best we could do was to compare the data of the current, which was a number of years ago now, to the data of a similar field of what we had converted it from. So we had a fescue field on this hillside, we had our diverse native grassland on this hillside, we dug down, and in that deeper range, we were somewhere around a foot. We found that we actually picked up 0.4% of organic matter down there. And again, these are not scientific studies, we didn't replicate them, but these are our observations that we enjoy sharing with people so that we can begin this conversation about the impacts of a diverse native grassland on the land, on the soil health. So if you can picture the root system of a big bluestem plant going down and down and down 15 feet or something, you can begin to picture that we can build organic matter through that whole profile. If our plant only has a shallow root system, then we can only build organic matter in that very top surface. So a couple things are going on to help us build this organic matter that we saw. One is those deep root systems, but another is a diversity of plants. When you have a diversity of plants growing in multiples of seasons, you're just able to produce more plant material. You're able to turn more stuff into organic matter. You have more interaction with the soil life down in the soil with those plants. And so the organic matter increase is due to this diversity of plants, we feel. So the consequences of organic matter increase in our soil, if I think in terms of water, of course, it's interesting, but the impact on the plants is huge. Here we are, it's the 6th of June today. We haven't had a significant rain in a while. these plants they're depending on that soil, that sponge in the soil, to absorb that water when it rains a month ago, and to hold it for days like today when it's hot and dry and there's really no promise of rain in the future. And so that organic matter is that sponge for the plants. And of course, if we're growing forage, that's very important to us. But even just for the health of the plants and the health of the ecosystem, we want the organic matter in the soil, because it also supports, it's the food for the soil life, for those microorganisms. It's the basis of our soil health. It's the food for them, it's the home for them, it's providing the water, of course, holding that water for them. The organic matter also holds our nutrients. Some nutrients, when they're just sitting there in the soil, they want to leave. And so if you think of, oh, well, you had a plant that died, and that plant, the nutrients went back into the soil via the microorganisms. And if there's not a plant growing there right then, the nutrients can escape into the environment and leave, like in the water even, down into the water table. And then they're not usable by plants, and they actually become a pollutant in things like the Gulf of Mexico with the hypoxia issue. So the consequences of this organic matter is that we can hold water for the plants, the microorganisms. We can keep our nutrients at home where they belong, rather than sending them down to the Gulf of Mexico. And from the environmental standpoint then too, if you want to talk about carbon in the air, some people have concern about this. So the carbon in the air is basically turned into organic matter in the soil. Since I'm involved in agriculture and of course natural resources, I tend to talk about organic matter. But for those who like to talk about atmospheric carbon, we are capturing that in the organic matter in the soil. So if we can store it there, then it's not in our atmosphere. Water in the soil health, it's a series of events in nature. First, when it rains, that water has to get into the soil. I refer to this as the land that drinks in the rain. The land is drinking in that rain. The second one, which we have discussed today, is that the water is held in the soil with the organic matter. And the third one is we don't want to let it escape back up into the air, and so we protect it from that. So it's a three-part series, in effect, in nature. And so we've actually made a three-part series of this in videos, and you can see the other ones here. So I've been Elizabeth Hamilton here with you today, and I'm part of Hamilton Native Outpost, where native grasslands and soil health are something that we're really passionate about and love to share with others.